All right, welcome to week 17, video 1. This is going to be the last week when we have videos you need to watch. So this week you're going to learn about pyramids, cones, and then also spheres, but remember, you can't really make a sphere out of paper. Um, we're going to talk about the lateral area, the surface area, and the volume of these three different types of 3D solids. Again, that's pyramids, cones, and spheres. We're also going to learn some new vocab this week. Next week, you're going to have a quiz and a project. And then week 19, which is the last week of school, is going to be kind of a catch-all week where just in case you need to make up any quizzes or if I need to assign you something to fix your grade a little bit, that will be the last week for you. But most of us will be done at the end of next week, which will be in June. So your project will be due Sunday, June 7th. So that way I have the last week, week 19, to grade your projects. And to work with any of you if you have a special situation where we need to revise your grade. So it's kind of a wrap up for what our last couple weeks in class will be. This is kind of like your last week of actual instruction because next week is just quiz and a project. So let's get started. That one new vocab word we're going to talk about today is called slant height, and actually have it drawn on all of our shapes here. All right, and it is symbolized with that S for slant, and it means the height of the face that's on the lateral surface. So notice that it's on the actual shape itself. The height of these pyramids and cones run through the center, kind of like if this was a tent, right? The height would be a pole that touches the vertex and goes straight down perpendicular to the base. The slant height is not perpendicular, right? It's at an angle on all of these shapes because the sides are angled, right? And that's the difference. So when we find the lateral area and surface area, we're going to use the slant height because that's the actual height of the faces. When we find volume, we're concerned about the inside of the shape, how much space that takes up. So we're going to use the actual height, which is an H, of the shape. And we'll look at some diagrams in the next video for that. But it's important to know the difference because these are actually different values. So let me demonstrate that. So here on this pyramid, this is a triangular pyramid, right? Because the base is a triangle. I'm going to try to find the height. And it's going to look weird because of the angles of the camera. But the height is about right here, right? Yeah, okay. So that is the height of this pyramid, H. All right, so we can kind of see, that looks about right. Slant height is different though. So if I actually bent it up and actually measured it like this, right? I don't have a ruler in this room right now. But we can see how different these two values are. So it's very important that you know which one we use. Height we use for volume. Slant height we use for surface area. Lateral area and surface area. So it's very important to remember which one's which, how we do it, and how we plug it into the formulas that you'll see in the next video. The next thing I just wanted to demonstrate for those who are curious is how do we get the formulas that we're going to use in the next video. So in the last week video, we talked about these formulas are based on stacking the bases up on top of each other, and that's why we do the area of the base times the height to find volume. But in a pyramid, right, the base gets the slices of the shape get smaller as we get closer to the vertex. So it's not just going to be the area of the base times the height. Instead, it's going to be a bit weirder. So I have an oblique pyramid. We didn't really talk about how to find the volume of an oblique pyramid. It's the same as a regular pyramid. We take the area of the base, an oblique prism or cylinder. It's just the area of the base times the height. But here, the special thing about these oblique pyramids is if we took 3 of them, we can make it into a cube. So this demonstrates for us that, the volume of this cube would be the base of the cube times the height. But then if we break it up, we get 3 different pyramids from that one prism. So the volume of a pyramid is not a half of a prism. It is not a quarter. It is a third. This is a weird thing. At some point, someone discovered that it is that nice clean fraction, and it's the same for all types of prisms. If we can make a pyramid out of it by cutting it into thirds. All right, it is a very nice coincidence of our math. If I had something more like Play-Doh, I could show that if we had a cylinder that had the same base, I could divide it into 3 cones that all had the same volume and had the same base and height of the cylinder itself. But that's not too easy to do with the circular shape. It's a lot easier to do with a cube like this. All right.